Yeah. Okay, cool. So I'm going to update you all on some stuff that I've been working on. And I just want to say, let's see if this presentation works. Nope. Play from start. Cool. So I'm going to update you on some stuff I've been working on. I didn't have an awful lot of time to prepare for this meeting, so apologies for some of the slides, and then we can talk about stuff at the end. So this is, I don't know if the number here, Pandemic Isolation Day 34.2 is accurate, but it certainly feels like longer than that. So my motivation here is that contamination is really rife in a lot of genomes, and we have two different projects, more or less, that I've been working on, both Sourmash based. One is computational contamination metagenome assembled genomes, and that's the charcoal project with Taylor. And then real contamination in eukaryotic genomes, long read assemblies. You can see GitHub for some of the source code on this. So let me see if I can, okay. So there's two basic approaches with k-mers. One is to use phylogenetic information. That's kind of what charcoal is doing. And another is to use database search, for example, gather. And that's what the long read decontamination is doing. Right, and one was with Taylor and one was with Eric. So I know we're all busy on time, so I'm going to be brief, and I'll just skip some of the background and go through these first slides quickly. So a really quick intro to charcoal is that if you take like an isolate genome.
Can I ask a question?
Yeah, Taylor, can you just hold on? I'll take questions at the end. Okay, so a really quick intro to charcoal is like we do these plots of hash togetherness vectors using angular similarity, and then we cluster and output the plot. The Python code is right here. You take presence abundance vectors for Sourmash across a bunch of metagenomes, and then you compute the angular similarity between those vectors, and so you have sort of a hash by hash matrix. You can see like in the clustering, there's a bunch of hashes that cluster together across metagenomes, and there's like some that aren't together. And we're hoping to use this information to figure out which bits of which genomes don't really belong together. And then we add some taxonomic information in here. So you can see like in this particular contaminated genome, Zeller something or other, there's this P firmicutes plots here. And we're thinking that this may indicate that these contigs are not like super good. So, that's the background on the charcoal project. And then the other project that we've been working on is this long read assembly decontamination. And here we piloted two approaches. One is running individual contigs against all the microbes. And so this is from an issue that was opened, I guess, just a couple days ago. We have this gather by contig approach. And what the gather by contig approach does is, I don't know if you can see my zoom, but it sort of tells you how many KB of different contigs of different potential contaminants there are in like long read assemblies. This is for a worm, so Bacteroides and Salmonella and E. coli shouldn't be in there. And then on Sunday, I got inspired and I wrote a snake make workflow that like did a gather on the whole thing where we're running the entire assembly against all the microbes, and then going from that and taking those matches and like isolating individual contigs. And this is like, because of the way gather works, basically giving more information, the entire assembly is a better approach. And if you want the background on that, just see the Sourmash docs on gather. So basically we're seeing that running Sourmash gather against everything is really like way more specific and equally sensitive. Eric has an old benchmark, has an old data set that we've run this on, and we're like updating it with the new one. And if it works well and matches everything, because he's already validated that, we'll consider publishing a small article. And so that would be something with Luis and Taylor. So, okay, so that's my lab presentation. And I hope you all realize that that was a terrible lab presentation. And I basically did this as a demonstration of how not to give lab meeting or remote presentations. Tracy inspired this when I was out talking to her about how I have to give some remote presentations in the next couple of weeks. And we were inspired by Greg Wilson's videos on how to teach badly, which you can access here, which are really, truly, tremendously awesome.